everyone, my name is Vikas. Today I am going to explain the COA program, which is factorial of a given number. The program starts at the memory address 00H, load the number n, move it into the register R0, which acts as a counter. For example, if n is equals to 5, then R0 is equals to 5. This handles the special case where 0 is not equal to 1. Next, move A into R1, load current factorial result into accumulator. Now move B into R0, load current counter into register B, where next we have to multiply using the mul function. After that, move R1 into A, then D Z N Z R0 factor loop is used to factorial loop decrement R0. Next we have to move A into R1. Move into R1. If R0 is equals to 0, exit loop. This repeats until R0 is equals to 0, meaning all numbers have been multiplied. After the loop ends, R1 contains the factorial, which is a 8-bit form. Then it moves to 8, then stores the memory location 61H. Then after that, SJMP, which creates an infinite loop to stop execution. Then if n is equals to 0, the factorial is 1. So it stores the 1 at 61H. And last end, here is the execution. After running, we have to enter the number first. At the address 60, and here is the result. I'm going to explain the second program, which is the GCD of a given number. ORG00H is the program where the address will start LJMP start, which is the long jump to the label start, which skips the interrupt vectors and jumps directly to the main program. Next, start move 62H address 30 Hz, which will store the memory address as 62H. Next, move 63H 12 Hz, which will move to the memory address 63H, which will store the value 18. Next, call GCD sub, which is called the subroutine that computes the GCD. Next, short SJMP, which will keep jumping to the same address so that the program stops running further, acts like a halt. Next, GCD sub, move A to 62H, which will store the value at R0 as the first number. Next, move A 63H, which will act as the second number, which will be stored at R1. Then G loop. Now the algorithm will repeatedly subtract the smaller number from the larger one until both are equal. Now move A, R0, load number, which will load the number into the accumulator. CLRC, which will clear the carry flag from before subtraction. SUBB A, R1, which will subtract the R1 from A. A is equals to R0 minus R1. Next, JZ, J is equals to equal. If the result is 0, numbers are equal, GCD will be found. If JC, R0 is underscore less, if the result is equals to 1 and R0 is lesser than R1, just jump to the R0 less. Now move R0, A. Otherwise, update R0 is equals to R0. R1, this is the difference. Then SJMP, G under loop, which will repeat the loop. Now next step, R0 less. Move A, R1. Clear C, which will clear the program before subtraction. Then subtract A, R0, which will subtract. Next, again move R, A, then again SJMP G loop, which will again jump to the loop and start the looping process again. Let's move 64H A, then RET function is used to return to the main function, and end function is used to mark the end of the source file. Now we're going to run the program. First, you need to debug the program. Next we have to enter the numbers, which is 30 and 12 in the 62 address, and here is the code. Here is the third program, the squares of the n natural numbers, org00h and ljmp start, where the resect vector will be placed at the org00h and ljmp will jump to the start, and org0030h is the main code starting at the program address. Now start move A67H will load the n value into the accumulator A. Next move R5 comma A copy, which will copy n into R5, and R5 will be used as a loop counter. Next move R3 at the address 0 1 Hz, then which will set R3 is equals to 1. R3 is the correct index I, which will have the values like 1 2 up to n values. Next clear 68H and clear 69H which will be cleared the 16-bit accumulator. Next JZ done. If A is equals to 0, then it will jump to done to skip the loop. Next the loop move A comma R3 B comma 3 are the prepare operands. Next multiply AB which in the operation mul, which will compute R3 into R3, which will result like low byte A and I byte B. Next we have move R4 comma A, which will save the low byte of the squares into R byte, which is temporary. Next move A comma 68H, next which will add the low byte to the square of low sum values with no carries handled here. Next move 69H, move A to 69H. So here the I byte values will be added to the square plus the carry from the previous add values. Next we have increment R3. Increment R3 means which will increment the index to the next integer. Next D, J, N, Z, R5 loop, which will decrement the R5 loop from count remaining numbers. If it is not 0, it will again jump to the loop. Next E done SJMP dollars, which is a short jump and again a short jump. Next end is the end is used to end the program. Now output, first we have to debug the program. Next we have to enter the numbers. Here is this square of n. After run the program, here is the n output for the square of n natural numbers. The last program, which is the square of a number, org00h and ljmp start, which will set a vector and jump to the main code. Next start move A comma 65H and move R2 comma A, which will load the n from the data memory 65H into the accumulator A, then copy into R2. Next move R3 comma address value of 00H and move R4 which is the hash 00H, which will clear R3 and R4, which will hold the 16-bit running product. Next move A comma R2, move R5 comma A, which will copy the R2 into A, then into R5. R5 becomes the loop counter, number of additions to perform. JZ store result, which will store if the A is 0, jump to the store result. If JZ tests the 0 flag from the last move. Loop add, move A comma R3, then add A comma R2. Move A comma R3, which will load the low byte of the accumulator into A, and add A comma R2, which will add n to the low byte. Next move R3 comma A and move A comma R4, where move R3 comma A, which will store the updated low byte back to R3 value. Now move A comma R4, which will load the I byte into A. ADDCA hashtag 00h, which will add carry from the previous add function into the I byte. Adding from just propagates carry. Move R4, A, which will store the updated I byte. Next, DJ and Z R5, which will decrement the R5 value. Then loop add, which will decrement loop counters if 0 repeat. Each loop will iterate at n. It's the 16-bit accumulator. Next, store result. Move 66h, R3. Means R3 is the low byte and it will move to the 67h. R5i stores the final 16-bit product in the data memory. SJMP dollars, which will halt the program with the infinite loop, and end is the end of the program. Now we have, for the execution, first we have to debug the program. Next, enter the values at the 65h memory and run the program, and here is the output. Thank you.